Where are you? Are you your face, your DNA, your memories, or your brain? If we strap your head into someone else's body, is that you walking around in your body? Or if we put someone else's head in your body, did you just become them? Today, we dive into one of the most controversial and fascinating medical proposals ever made, the head transplant. The 20th century had barely begun. The Wright brothers had just flown. Electricity was still a marvel, but in the surgical labs of University of Pittsburgh, Dr. Charles Claude Guthrie had something far stranger in his mind. Long before transplant was a medical commonplace, Guthrie wasn't thinking about immortality. He was thinking about anastomosis, the science of sewing artery. He decapitated a dog and connected its head to the host dog. He did not and could not reconnect the spinal cord. The second had survived for hours. It blinked, pupils reacted to light, the tongue moistened the lips, the brainstem reflexes were preserved. Again, Guthrie wasn't chasing immortality. He wasn't asking what it means to be you. He was studying healing, circulation, and how tissue survives. What he created was the world's first living two-headed animal, and the first hint that a brain could live without its body. While the West watched Cold War unfold, behind the iron walls in Moscow, a man was pushing surgical science into eerie new territory. His name was Vladimir Demikhov, a pioneer in organ transplantation, but he would be remembered for something far more bizarre. Demikhov didn't want to study blood flow. He wasn't interested in consciousness either. He wanted to transplant entire organs, lungs, hearts, limbs, but the head was the ultimate challenge. He attached the head, forelimbs, and upper torso of a puppy onto the neck of a mature dog. Not just once, he performed the procedure 20 times. Unlike Guthrie's, Demikhov's second head could swallow, vocalize, even express discomfort. It responded to stimuli, drank liquids, bit fingers. It was alert. Unlike Guthrie's experiment, it wasn't just reflex. The second head wasn't limp. It behaved almost like wanted to live. But still, no spinal reconnection, no control over body, no way to move beyond the neck. About the cognitive awareness, we can't be sure. But there were hints. The puppy turned towards voices, licked hands, even growled at strangers. However, the immune system did not cooperate. In every case, rejection came. The smaller head would darken, swell, and finally fade. Most of these creatures died within days, some within hours, one a full 29 days. To some, it was grotesque cruelty. To others, a miracle. To Demikhov, it was just progress. By now, men had walked on the moon. Organ transplants were becoming reality. But the neurosurgeon Robert Wright had a different dream, a far darker and a far more radical one. Could he move not just organs, but a consciousness? He asked. Unlike Guthrie and Demikhov, White wasn't interested in stitching heads onto bodies. He wanted a true transplant. Two rhesus monkeys, one donor, one recipient. White cooled both brains to 10 degrees Celsius to slow metabolism. He then cut the donor's head clean and connected it to the blood vessels of the recipient's body.
We now have separated the head from the body, which has been removed.
No spinal cord was reconnected. Hence, there was no motor control. But within minutes, the monkey's new head woke up. The eyes opened. The monkey didn't just blink. It looked It followed people in the room. Its pupils responded to light. Its face flinched when touched. It tried to bite a staff member it had recognized from before the surgery. This was not a new animal. This was the same brain in a different body. The monkey knew who it was. Its sense of self, its consciousness, had crossed over. For the first time in history, we had a real testable evidence that you, in your head, your memories, personality, perception, could be transferred. But without the spinal cord, the body was still a cage. It couldn't move, couldn't breathe on its own, couldn't speak, no motor control beyond the neck. And within days, the immune system did what it always does. It couldn't let a stranger live. It turned defense into death. The monkey's brain had made it, but the medicine hadn't. The body shut down, the mind went with it, and the world moved on. It's been half a century since Robert White made a monkey wake up in a new body. Since then, we've gone to Mars, sequenced the entire human genome. We've transplanted face, hands, uterus, even a penis. We have grown miniature organs from stem cells, cloned organs in pigs, kept human art alive for 12 hours outside the body, connected brains to computers, typed with thoughts, even saw a baby born from a transplanted womb. The line between science fiction and medicine has blurred. And still, no one has ever transplanted head of a living human. Not once. Not even tried. But why? What's the problem? If we are so far ahead in our technological capability, then what's stopping us? There are two things. Two very specific things. And until we solve them, the head stays where it is. First, spinal cord fusion. One of the biggest obstacles. Something we can't even conceive a solution for yet. The spinal cord is central. Every voluntary or involuntary signal from the brain to the body, walking, speaking, digesting, even breathing, must pass through it. In a head transplant, you can't just move the neck. You have to cut the spinal cord. There is no other way. You can't transplant the entire body upward. The immune system would attack every single organ. You can't keep the original body. That defeats the entire idea. The cord has to go. But the spinal cord is not like the bone or skin or even nerves in your limbs. It's a dense highway, hundreds and millions of axons, packed tighter than any structure in the body. Each one of them is a long thread-like extension of a neuron. And here is the problem. Axons in the spinal cord don't regenerate, not in humans. If you cut them, they die back. The end shrivel, scar tissue forms. They don't grow back across the gap. We don't even know how to make them line up again. Because it's not just one bundle, it's thousands. Each one with a specific origin and a specific destination. For over a century, researchers have tried everything. Polyethylene glycol, fibrin glue, stem cell bridges, gene therapy, electrical stimulation. They've had some results. A few spinal injuries have shown partial recovery, but a complete spinal transection, a full cut, has never been reversed in a human. Not once. Even if the blood vessels connect, even if the brain survives, the moment the spinal cord is cut, the person is paralyzed forever. No movement, no speech, not even autonomous breathing. The head can wake up, but it will always be trapped. Second, immune rejection. Let's say we have done it. The head of one human, complete with brain, spinal stem, and vascular network, is successfully connected to the body of another. The blood flows, the heart beats, the eyes open. But now, the war begins. The immune system is ruthless. Its job is to distinguish self from non-self. It checks molecular ID badges called HLA markers on every cell. And when it doesn't recognize one, it triggers a war. The immune system doesn't care how perfect the stitching is. It doesn't care that the brain still holds memories, emotions, a lifetime of thoughts. It sees something foreign and attacks. That's what happened in all the past experiments. The graft was accepted for a few hours, maybe a few days, and then the immune system killed it. Even worse, the reverse can happen too. The head comes with its own immune tissue, and it can start attacking the body it's sitting on. It's rare, but it's real. It's called graft versus host disease. Back then, there was no manual for what to do, and both the donor and the recipients are trying to kill each other. However, in the last decade, we've made huge progress. We've fought back. Drugs were created to shut the body up, to make it look away when a new organ arrived, to stop it from screaming intruder every time a foreign cell showed up. And in many ways, they worked. We call them immunosuppressive drugs. Today, we can transplant a heart, a liver, a face, and keep it going sometimes for decades. But all this happened for a cost. These drugs suppress everything, not just rejection, but defense. Infections slip in, cancer risk rise. Your immune system become polite, too polite. And even then, the head is different. A kidney doesn't think, a lung doesn't remember. But the brain, even one inflammation at wrong place can decay your consciousness, can make the person lose his memory. That's where we are. Progressed, but probably not enough. We bought time, we flowed the war, but we haven't stopped it. Among all these, there is one recent name I have to mention. A scientist who didn't just dream of head transplants. He said he will actually do it. His name was Dr. Sergio Canavero, an Italian neurosurgeon. And his claim was that he was going to perform it soon. He called the project Heaven, short for Human Anatomosis Venture. To be clear, there was no breakthrough, no new fusion technology, no spinal repair. Yet, Canavero told the world he had solved it. He said he could cut the spinal cord, move into a living body, and bring it back to life. He wasn't just talking. He held press conferences, he did interviews. In 2017, he announced he had already performed the first human head transplant on a cadaver. It meant a head had been cut and stitched into a dead body. No consciousness, no spinal fusion, no waking up. Just a practice round, a surgical stunt, and even that was never published in a peer-reviewed journal. Just a photo. And the media ran with it. Some called him visionary, others a madman. Canavero chose his first real patient, Vladimir Spiridonov, a Russian computer scientist suffering from a severe genetic disease. Valery was paralyzed, wheelchair-bound, and terminal. He volunteered for the operation, desperate for any shot at normal life. Canavero claimed he could carry real procedure in China with the help of surgeon Dr. Xiaoping Ren, a Chinese doctor with experience in animal spinal work. But why China? Because no hospital in the West would allow it. Every ethics board in Europe and USA, even in many parts of Asia, refused. The surgery had zero precedent, zero published validation, and zero chance of approval. Eventually, even Spiridonov backed out. He said he no longer believed that the science was ready. He married, had a child, and chose to focus on real treatments. As for Canavero, he faded into the background, and the operation never happened. Why head transplant and not brain transplant? If the goal is to move you into another body, why not skip the entire head and just transplant the brain? After all, isn't it where you are? To some, that sounds cleaner, less gruesome. No facial scars, no jaw muscles to reattach, no skull to carry over. Just take the brain, real state of identity, and place it into a new body, new skull. Easy, elegant. Except it's not. Because, first, the brain is not a USB stick. It doesn't just plug in. It's more like a living coral reef, fused into its environment, dependent on it. It relies on an incredibly complex web of nerves, spinal cord, autonomic fibers that control vision, balance, facial expression, heartbeat, digestion, breathing, and more. A standalone brain doesn't do anything on its own. It doesn't see, it doesn't hear, it doesn't breathe. It just is. Once you take it out of the skull, you have severed every connection that lets it experience the world. Second, and this is the real killer, the blood-brain barrier. The brain has its own immune system, its own chemistry, its own rules. It's guarded by a filter so selective that most drugs can't even get through it. It is designed to reject what doesn't belong. Trying to connect brain to a new blood supply, a new spinal cord, that's not transplantation, that's war. Even if the brain survives surgery, inflammation alone could wipe out memory, cognition, identity, everything that you're trying to save. And then comes a real nightmare, reconnecting. We don't know how to revive a spinal cord. Transplanting the brain is even worse. You'd have to reattach dozens of cranial nerves manually, one by one. The optic nerve for vision, the vagus nerve for heart and digestion, the facial nerve for expression and speech. No surgeon in history has ever reconnected those. Not once, not even close. And the irony is, a head transplant, as I said before, may look crude, brutal, and grotesque to some, but in today's terms, it's actually much simpler. Because the head carries everything the brain depends on. The blood vessel it already knows, the cranial nerve is already intact, the skull that shields it, the face that lets it speak. That's why a head transplant, and not a brain transplant, is the only idea that anyone has even considered seriously. As broken as it is, it's still the cleaner option. But how far are we? A successful head transplant with a full spinal reconnection? That looks at least half a century away, and that's being optimistic. We haven't even done it on animals, not once. Even the most advanced rodent experiments have only scratched the surface, and none have reversed a clean spinal cut. As for a brain transplant, where we remove the brain alone, reconnect cranial nerves, override the blood-brain barrier, and preserve identity, right now it's not even science. You're probably looking at a century or more before it's even consumable.